Miss Menisa A. Antonio. She's a senior science research specialist at Mariano, Marcos State University in the Philippines again. And she's doing PhD in botany. And it's really nice to hear from researchers, new fields. And she's going to speak upon harnessing Allaeanthus luzonicus of Phenocalendar-based production for household food sufficiency in northern Philippines. So over to you, Ms. Menisa.
A pleasant day, everyone. I am Menisa Antonio, and our research is on a tree species, the Allaeanthus luzonicus. I have titled my presentation, Harnessing Allaeanthus luzonicus, a Phenocalendar-based production for household food sufficiency in northern Philippines. This is Allaeanthus luzonicus of the family Moraceae. It is commonly called bird's flower, and in the Philippines, we call it by several local names. We call it himbabao, alocon, or alibabag. It is a non-timber lesser-used tree species native to the Philippines and Sulawesi. It is notable not for its wood, but for its edible inflorescence, which is a regional indigenous vegetable or ivy, particularly in the northern regions of the Philippines. This species offers several opportunities. It has potential for food and nutrition, wherein the inflorescence together with the tender leaves are edible for various vegetable dishes. It produces a peculiar inviting aroma, adds texture, and provides additional roughage to any vegetable dish. When cooked, it turns vibrant green and a bit sleek or slimy. And in addition, it contains minerals such as calcium, phosphorus, iron, sodium, and vitamins such as beta-carotene, thiamine, and the like. It also has potential in drug development, and this is being currently evaluated through the drug discovery program of the Health Research Council of the Department of Science and Technology in the Philippines. It is rich in secondary metabolites such as flavonoid, phenol, steroid, and the like. And in one of our projects here in the university, we found out also that this Allaeanthus is a good antioxidant food. In fact, when compared with 5 other indigenous vegetable species, it had the highest radical scavenging activity. And then we are also eyeing it to bridge the gap between vegetable supply and demand to elevate the present level of 40 kilogram per capita into the recommended 150 kilogram per capita consumption in the country. And there is also a little potential for furniture making. But in realizing these opportunities, we are constrained by the unsustainability of supply due to several reasons. And so some interventions were introduced to harness its potential through R&D, and one is through leveraging a species phenological calendar for a sustainable food production. So the objectives of our study, we documented the growth and development stages, morphological and reproductive characteristics, determined accompanying changes in the plant at its event in the phenological cycle, and identified weather variables affecting the phenological events, as well as identified ongoing changes in the phenological cycle. So what we did, we selected and observed trees that grow independently in the 4 ecological zones in the province of Ilocos Norte. We monitored them for 3 years. We did the monitoring weekly during the reproductive stage and bi-monthly during the vegetative stage. Phenological events and flowering periods were particularly recorded. Phenophase descriptions are adapted from the Project Budburst Phenophase Field Guide, and the methods were adapted from the National Phenology Network. Weather data were also gathered from the 2 weather stations in the province and from automatic weather stations installed in different areas of the province. And then several trees were also identified and monitored in the provinces of Cagayan and Apayao. These are nearby provinces to Ilocos Norte, to compare the effect of different climate types and the phenological cycle of the species. So this is the location map of the sample trees that we observe. On the left is the province of Ilocos Norte, which has a type 1 climate, and on the right are the trees in the provinces of Apayao and Cagayan, which has types 2, 3, and 4 climates. Now, as a result of our characterization activity, we were able to update the botanical description of this species. We included in particular characteristics of the flowers, the inflorescence, and then the flowering habit. Allaeanthus luzonicus is a dioecious tree. The staminate plant produces an elongated catkin at the left, measuring 3 to 58 centimeters long, while the pistillate plant produces globose to subglobous head, measuring 2 to 3 centimeters in diameter. In the locality, our local folks used to say that the elongated catkin is the female one, but in reality, this should be the male one. So we often highlight this information in our presentations or talks in the locality. Now, in terms of flowering behavior, there are 2 documented flowering habits, either synchronous or asynchronous. The synchronous habit is characterized by distinct vegetative and reproductive phases following the developmental cycle that we will be describing in the succeeding slide. The asynchronous habit, on the other hand, is characterized by 2 or more stages occurring simultaneously. For example, there is simultaneous vegetative, leaf falling, and flowering phases happening all together at the same time. This is the documented growth and development phases of the species, and generally consists of the vegetative and reproductive phases. But there is no clear-cut delineation of the end of the vegetative phase and the start of the reproductive phase in this tree. In this paper, we call that phase as the intermediate phase, which corresponds to the post-vegetative and pre-reproductive changes that occur in the plant. The vegetative phase lasts for 7 to 8 months, usually in the month of March to October, and this period consists of leaf bud emergence, full leaf development, and leaf maturity and senescence. Now, the reproductive phase is usually from 4 to 5 months, from November to March, and it is characterized by floral bud emergence, inflorescence market maturity, as well as physiological maturity. Now, the intermediate phase is usually characterized by the deciduous changes, which consist of leaf yellowing and abscission, and then the leafless stage. This period usually lasts for 1 to 1.5 months and 3 to 4 weeks, respectively. This phase usually happens in the months of November to December. Now, just to show the morphological changes in the tree at the different stages in its phenological cycle. So from full leaf stage up to, up to physiological maturity of the inflorescence. And this is the phenology in different ecological zones of Ilocos Norte. We have 4 ecological zones in the province, and we belong to a type 1 climate, which is characterized by 2 pronounced seasons. We have dry season from November to April and wet during the rest of the year. And we found out that regardless of ecological zone in our province, the regular flowering period is from January to March, and the peak is in the month of February. But then we also found out that there are other cases, extreme cases, which do not conform to this regular flowering period. So we call them off-season varieties. So we have early flowering in the month of December to January. We have late flowering in April to June. And we have long duration flowering from November or December up to May or June. Now, here is the flowering in the provinces of Cagayan and Apayao. The province of Cagayan belongs to 3 climate types. We have types 2, 3, and 4. Type 2 climate is characterized by no dry season with a very pronounced maximum rain period from December to February. Type 3 climate, on the other hand, is characterized by no very pronounced maximum rain period with a very short dry season lasting for 1 to 3 months, while the type 4 areas are characterized by more or less even distribution of rainfall throughout the year. And for the province of Apayao, there are 4 climate types prevailing in the province, but our study sites belong to types 2 and 4 only. And we found out that the regular flowering season in types 2 and 4 Cagayan and Apayao is, the flowering is in the months of January to March, but the peak is in the month of March. While in type 3 Cagayan, the flowering is in the month of April to June, and the peak is sometime at the late part of May. So with the regular flowering and off-season flowering varieties in these 4 climate types, we found out that it is only in the month of August when we cannot expect no flowers, or when we cannot expect flowering from our Allaeanthus luzonicus. And so we came up with this recommendation for a Phenocalendar-based production for year-round, more or less year-round supply of this indigenous vegetable. And for the month of January to March, the source would be from the province of Ilocos Norte, which has type 1 climate, and from Northwest Cagayan and the central part of Cagayan, which has type 2 and type 4 climates, and from the northern Apayao, which has the same types of climate. Now, in the month of April to June, the source of inflorescence would be from the rest of the province of Cagayan with type 3 climate. And from July to December, excluding August, we can make use of the identified off-season varieties, the early, the late, the long duration flowering varieties. And in the month of August, when there is no flowering, we can explore the frozen, the freeze-dried, or ready-to-cook formulations of the inflorescence, which we are currently optimizing in our university. And this Phenocalendar-based production system is simple and economical, does not entail cultural interventions nor chemical inputs, which we usually do when we do floral induction. So for our ways forward, we are recommending the validation of this Phenocalendar-based production system vis-a-vis our changing climate, and then mass propagation, field gene bank establishment, and additional planting are now underway. And lastly, cultural management interventions are also recommended to supplement the production that we can obtain from this Phenocalendar-based production system. And so that's my presentation. I am now ready to listen to your suggestions to improve our research or respond to your queries if there are none.
Thank you, Menisa, for being on time. We have got 4 minutes with us, so we can take a lot of questions. There's one question. Are there plans to propagate the trees in other areas?
Actually, based on the survey done by our colleagues from UPLB, from the National Plant Genetic Resources Lab, the tree is actually growing in other parts of the country up to Mindanao. But then we concentrated our documentation activities in the northern part of the country because we are the Alocon or the Allaeanthus luzonicus eating regions. We utilize this indigenous vegetable not as much as the other parts of the country utilize it for vegetable.
Yeah, this question was from Dr. Habito. Any other question, please? Any other query? Any
And
information?
in addition to Dr. Habito, we have one tree standing at the UPLB campus, ma'am. That's near the main gate, near the DevCom building po.
Another question from Dr. Habito. Could the
Yes,
other regions use the vegetable too?
Yes po. In Mindanao, there are plenty of Ilocanos. We call our group Ilocanos, coming from the Ilocos region. Many of our fellow Ilocanos are now living in the southern part of the country, particularly in the Mindanao Islands, and they are still clinging to the use of this indigenous vegetable. In fact, among us Ilocanos and other groups living in the northern part of the country, the use of this indigenous vegetable have indeed rooted in our food culture as well as in our daily diet, in fact.
Okay. Thank you very much, Menisa. And it was really very, very informative. And you have answered very well to all the questions of Dr.
Thank you
Habito.
very much, Dr. Gopta.
Thanks a lot.